So capacity, availability, and cost efficiency, pick three. Today we're going to talk about some techniques and approaches to help you understand how to maximize each of those areas to effectively get the results that you're looking for. So the key to successful capacity management is finding the right balance between performance, availability, and cost for your workloads. Ultimately, it's really about having the proper and effective framework to execute on your organization's objectives. Capacity strategy is a constant negotiation between availability, performance, and cost, and we're always going to want to be balancing those things out. Now, of course, every workload has unique requirements and objectives. On the one side of the AWS model, we have pay-as-you-go pricing, and that has several benefits: business agility, elasticity, efficiency, scaling. On the other side of that, we have capacity reservations, and that's where we're going to want to have capacity assurance, and we're going to achieve operational resiliency. But there's a very special place in the middle: flexibility. When we're able to combine all of those components effectively, we get into an area where we have a high level of flexibility, and that just opens up kind of a whole ton of new possibilities. I'd of course be remiss if I didn't talk about a little bit about from an AWS regions and availability zones perspective. As you can see, the infrastructure is robust. As of today, the AWS cloud has 102 availability zones with 32 geographic regions around the world. And that's going to be important in some of the points that I'm going to make here today in terms of leaning into flexibility, because flexibility is going to be really key here, and regional and location flexibility is going to be a very important lever that we can use to lean into that flexibility, to lean into that agility, and take advantage of kind of all the benefits that come along with that. So Amazon EC2 instance characteristics. This is one where I think a lot of folks are familiar with it, but I'll even admit that before I came to work here at AWS, I didn't kind of fully understand exactly kind of what was always being conveyed here. And so I think this is a great slide that kind of explains that and summarizes it into an easy to consume format. So when you look at an EC2 instance name, all of those components mean something, of course. So we have here the first letter, that's going to tell us the instance family. So CMR, right? C instances for, you have our M instances that are going to be kind of our general purpose instances. You've got C and R focused on compute and memory. So it's very important to, when we're thinking about what is going to be the most effective instance for our workload, kind of understanding kind of what those mean, because they definitely have impact. The number here in the middle is going to tell us that instance generation, and then the letter on the end there is going to inform us on additional capacities or capabilities of those instance types. So you'll see G for Graviton, which is our ARM-based instances of AWS Silicon. You'll also sometimes see N, network optimized instance, storage optimized instances. So you get a lot of information there. And then, of course, finally, it's going to tell us kind of the size there, and that's going to inform us there. So again, as we start to think about being flexible, being able to manage through for capacity and availability, kind of understanding those things that are core becomes really important. So as I kind of said earlier, it really is all about flexibility. Let's blow this out here. So AWS has multiple pricing models to help you optimize your cost. Now, on the far end of this, we have on demand. So this is going to be our pay for what you use, no long-term commitments, and that's going to, of course, be best suited for stateful, spiky workloads. In the middle there, we have savings plans, which offer significant savings for a 1 or 3 year commitment of hourly usage. And then finally, here on the far right, we have spot, which is spare capacity available at up to a 90% discount. And that's going to be most well suited for fault-tolerant, flexible, and stateless workloads. The line here at the bottom is really important because the best practice is to combine them all. I say this a lot, But when it comes down to customers, when customers want to know whether they should use on-demand or whether they should use spot or savings plans, I say the answer is all three, right? The best practice is not an either-or conversation. It is an and conversation. Another kind of key point here is that we want to always, as we're thinking about building out our architecture, we're building out our workloads, we always want to keep flexibility in mind. Flexibility is one of the most effective ways to avoid insufficient capacity exception issues and making sure that you have the capacity that you need when you need it. When we look here in the pyramid, of course, we have time, we have geography, we have instances. So kind of let's dig into that a little bit. The kind of easiest, I think, from my perspective, and one of the most effective ways when we start talking about flexibility is going to be maximizing instance flexibility. So this is going to be, am I leveraging instance types across multiple different instance families? Am I leveraging multiple different instance sizes? Right, so we're going to want to take advantage. We're going to want to take advantage of that. The second level up in the pyramid, of course, is geography. So being able to take advantage of multiple AZs, or availability zones, excuse me, to be able to maximize your access to potential capacity is always going to be very, very important to being able to maximize your overall flexibility. And then time flexibility. Time flexibility is actually an interesting one, especially when leveraged with spot, for instance, as a purchasing model. If you are able to take advantage of the different usage patterns for a purchasing option like spot, where workloads come online during the day, and then during the evening time, workloads get spun down. If you have the time flexibility, then you're able to pick up that capacity that's been vacated and leverage for your own purposes. The same thing for weekends. Right, so when workloads go offline over the weekend, if you're time flexible, you'll be able to come in, run your workloads in that vacated capacity, and use that to help to optimize and maximize your cost savings. So definitely a technique that you want to think about and take advantage of if your workloads have that flexibility as well. So kind of further digging into flexibility in the cloud and kind of the benefits. So the benefits are many, and of course I won't cover them all today exhaustively, but there are a few that I did want to point out. So of course, being flexible in the cloud allows us better scalability via elasticity-related services and features, right? So this is going to be things like auto-scaling groups, fleets, things that allow us to combine multiple different instance types, multiple different purchasing options for whatever purpose that we're looking for. Again, it also provides us higher availability by using more capacity pools, AZs, and regions. That becomes particularly important when we think about things like spot, as we talked about a little bit earlier, and being able to leverage and maximize the most capacity pools possible. So when you think about capacity pool, every instance type and size in a particular AZ is its own capacity pool. So in a situation like leveraging EC2 Spot, which of course is AWS spare capacity, the more unique capacity pools that we can access, the higher the odds are that we're going to get the capacity that we're looking for and be able to execute our workloads in an efficient manner. And then finally there, lower cost through the right purchasing options for your workload. Again, like we talked about a little bit earlier, ultimately, it's going to come down to kind of your own discretion in terms of what the right combination of options is, but know that you have the power to combine them all, either at an architecture level. So if you're talking about a larger enterprise strategy in terms of how you want to bring these purchase options to bear, or if you're talking about at a specific workload level. So you see a lot of times in media type workloads where you'll have a component of the workload that is most well suited for on-demand. You need that particular component to be stable and available, but there are other components that are a little bit more flexible, and that's a place where we can take advantage of leveraging spot instances for scale as well as cost optimization. So we always want to select the instance types that fits our needs. I actually think this slide might be a little dated. 650 plus instance types. I want to say that number is now 750 plus different instance types. So virtually an instance type for virtually every need you might possibly have. But when we think about what is the right instance type for our needs, we have to consider kind of multiple questions. So we're going to want to ask ourselves, what processors can my workload use? And this is important. It's increasingly important because of Graviton, right, which is our ARM64-based instances. So when you start, they have the best price performance in their respective instance families. So when you start to think about what instance types are going to be most suitable for your needs, you absolutely want to expand and think about outside of the x86 kind of framework. So Graviton instances are extremely versatile, extremely flexible, and when you start looking at the sizing and the capability, you'll find that there is increasing parity on the ARM64 side as well as with the x86 side. So it's definitely something that I recommend that customers always look at and evaluate. There's tremendous value to be found there. A bonus tip I will say is that when you think about Graviton, I know it can be at an architectural level, it can be a significant change. If you're looking for a lower friction way to kind of get started with Graviton and be able to kind of take advantage of it and understand kind of the value, I definitely recommend checking out managed services. So things like RDS, Aurora, Elasticache, OpenSearch. Those are excellent ways to get exposed to Graviton, be able to take advantage of some of the price performance benefit in kind of a lower friction way. And then once you've been able to achieve the value there, then you can look to adopt it a little bit more aggressively. Kind of another valuable thing that we're able to leverage there is something called Porting Advisor for Graviton, which will allow you to do some type of assessment to understand kind of I would say kind of the level of effort that will be required when migrating to Graviton. So it will scan the source code, it's open source, and it will scan the source code of your application and give you a report about outdated libraries and code constructs along with recommended alternatives. So that's something that I feel like is kind of very powerful when we start to think about maximizing our use of different instance types and different processors in particular. Kind of the next thing that we want to always consider is what are my workload's performance requirements? So again, this is one of those areas where we really want to think about and get granular in terms of what are the needs of our workload. Is our workload more memory intensive? Is it more compute intensive? Is it more balanced? And then we want to use the answers to those questions, and we've got some detail a little bit later, but we're going to use the answers to those questions to inform our approach to how we acquire capacity, how we think about availability, and then how we use these different techniques to optimize for cost. The third kind of bullet here, of course, is what is my workload consumption pattern, right? So is my workload steady? Is it spiky? Again, that is all going to inform the strategies that we use, the purchase options that we leverage, the things that are going to provide the biggest benefit. Ultimately, the result of answering all these questions internally for you should be a flexible list of instance types that are well suited to your workload. The flexibility tool set. So the great thing about this is we have lots of different tools and techniques available to help you do this. Everything from auto-scaling groups, EC2 fleet, attribute-based in selection, and spot placement score. So auto-scaling groups are, of course, very powerful. They allow us to combine multiple different types of instances, multiple different purchase options to achieve kind of our target objectives. Spot placement score is another one that I really want to talk about if you're thinking about using Spot, if you're a heavy Spot user. One of the things that customers are constantly trying to understand when leveraging Spot is kind of availability. Where is Spot going to be available? And Spot placement score is great for that because you're able to kind of enter your requirements for the Spot capacity that you'll need and get a score returned back at both a region level and an AZ level of the likelihood of successfully getting the Spot capacity that you've requested. So an example in workloads that we find this used heavily with is EMR, for example, right? So you want to know that the capacity that you're looking for is available in a specific AZ so that you can determine the appropriate AZ to launch the EMR cluster in. So while it's generally very applicable, EMR workloads are where I see most customers using it very effectively. There's also a spot placement score tracker that is available via GitHub that allows you to track that score over time, right? Which is very important in terms of trend management. And so you're able to see kind of spot availability over time and then use that to further inform your decisions. So attribute-based instance selection, now I really want to take a little while to kind of talk about this. This is by far one of my favorite features that we've launched since I've worked at AWS and probably since I've been working with AWS. Attribute-based instance selection really turns the idea of how we acquire capacity, how we think about capacity really on its head, right? Traditionally, before I worked at AWS, I managed a large team and you spend a lot of time trying to understand what instance types in particular will work for your needs, right? And you have a list and you're managing that list and it's a lot of overhead. What I love about attribute-based instance selection is it gets rid of all of that. It allows you to define the requirements of your workload via attributes. So if you have a specific vCPU to memory ratio that you're trying to maintain, right? If there's a minimum or a maximum on either one of those sides, you're able to specify those attributes and then get an output back of every instance type that matches the criteria that you've set. The valuable part of that, of course, is that it takes the guesswork out of it for you. You know that any instance that's going to be returned is going to match the criteria that you've set. And the amazing part about it, from my perspective, of course, is that it will expose you to instance types that you potentially would not have thought of on your own. It also has several benefits, including being price protected. What does that mean? That means that we're going to automatically filter out some of our more exotic instance types, right? So bare metal, accelerated instances, right? Because we want to try to help you optimize down for cost. It's going to allow us to almost instantly achieve instance agnostification, right? Because you're not telling it, I want a C, I want an M, I want an R. You're telling it, I want an instance type that matches this particular attribute profile. Then it's going to return a diverse set of instances automatically and then allow you to then deploy those into your environment. It simplifies provisioning because it's always running, right? So if AWS releases you run it, it starts working, you're leveraging all these different kind of instance types, AWS releases additional instance types. It's always running. So if the new instance types match the criteria that you've previously set, it'll automatically pull them in and start leveraging them for you. So we call it kind of future-proof in that way. You don't have to constantly maintain it. The only thing that you need to do is to establish the criteria for the type of instance that you want. Once you do that, attribute-based instance selection will take care of the rest. In the graphic, you kind of see vCPU and memory, but there are dozens of attributes. So if you want to run this and it starts returning Graviton instances, there's a CPU architecture attribute. So you can select and say, hey, only give me x86 instances in return. If you have specific storage requirements, networking requirements, kind of whatever those requirements might be, you're able to configure an attribute profile with attribute-based instance selection and then automatically kind of get that list back. Kind of as we see here in terms of being integrated with things like auto-scaling groups and fleets, attribute-based instance selection is also valuable even if you're not able to take advantage of the automated in an automated fashion. We find oftentimes where we need to understand kind of what is the largest, broadest set of instance types that will be suitable for our workloads. We still need to kind of figure that out. Attribute-based instance selection can be leveraged to do just that. So you're able to get the set of instances types that matches the criteria that you need, and then manually kind of input them. So it's definitely one of those cases where whether or not you can use attribute-based instance selection in an automated fashion or not, if you're looking to discover a diverse set of instances that meet a specific attribute profile, then I highly recommend taking a look at it. But ultimately, it comes down to what matters most to you. You'll see from this inverted pyramid, this is kind of just an example. You really would want to update it and reconfigure it based on the things that are most important to you. But ultimately, we want to start thinking about a few things. When it comes to capacity, we want to ask ourselves, is the approach that we're taking, is this going to secure the capacity that I need? And this becomes very important when we start thinking about business or mission critical workloads where you have specific SLAs and you need to know that you're going to have the capability that you're looking for. Is it cost beneficial? Can my workload leverage multiple instance types and sizes? Will this configuration provide the stability that I need? Of course, won't read all those questions there, but ultimately these are the type of questions that we want to be able to ask ourselves. And it's ultimately going to be different for each of us, different for every organization, and oftentimes every workload. But this is the kind of thought process we want to put ourselves through when we're thinking about what is the best approach to take. So savings plans. So of course, savings plans are a flexible pricing model that allow you to save up to 72% for committed usage against on-demand prices. The reason I want to talk about savings plans is because savings plans play a key role in kind of as the glue in a lot of cases, allowing us to separate the acquisition of capacity from the actual cost or kind of the discounting of that capacity. So, of course, savings plans allow you to commit to an hourly rate, and the savings automatically and simultaneously apply to your compute usage. So when we think about savings plans, there are kind of three major types. We've got compute savings plans, we have EC2 instant savings plans, and then SageMaker savings plans. Compute savings plans by far offer the most flexibility, up to a 66% discount, and they automatically apply to any usage across kind of the areas there, right? Regions, instance sizes, tenancy, operating system, et cetera. Instant savings plans provide the deepest savings at up to 72%, and then they're automatically applied to across instance sizes, operating systems, and tenancy. I really want to focus on the first two here, which is compute savings plans and instant savings plans, and kind of understanding for our purposes in terms of being flexible, optimizing around capacity, availability, and cost, kind of how they help us do that. So ultimately, for flexibility's sake, compute savings plans are going to be what we're going to want to leverage when we want to maximize flexibility, when we're not sure or when we want to maintain flexibility over time to take advantage of new instance types that are released and kind of give ourselves the most flexibility. But instant savings plans are very useful if you have a specific workload that needs a specific profile of instance type, GPUs, for example, right? So if you know that this workload is going to need instance type or a set of instance types with a specific profile, and you're going to be able to leverage those instance types over time, then EC2 instant savings plans are going to be what we're going to want to be able to use there. So it's really about ultimately what are our objectives and kind of what level of flexibility we're looking to acquire, and then using that to determine kind of ultimately what approach to take. Ultimately, the three key takeaways when we think about kind of savings plans here, and then ultimately how these will apply to some of the other concepts that I'll discuss, is one, it helps you save money on your steady state usage, right? So once you've brought a workload over to AWS, ideally you want to spend some time profiling that workload, understanding how it's going to perform over time. And then once you've been able to do that, then we're going to want to bring in savings plans to optimize our cost on that usage over time. The second point is that it's going to allow us to reduce cost when we want to modernize workloads. So this is important because as we modernize workloads, we often want to leverage new instance types, right? So we want to leverage a new instance type that maybe provides better performance. And so a compute savings plan in particular, right, that has that flexibility is going to allow us to be able to do that in an effective way. It also, of course, if we want to take it a step further and use things like Fargate and Lambda, then compute savings plans is going to cover that as well. So it's going to give us even more flexibility in terms of the strategy that we take as we modernize our environment and modernize our applications. And then lastly, it's going to allow us to centralize and simplify kind of cost management. You can purchase a savings plan in one AWS account and then have it AWS will automatically apply it across your AWS organization. So it kind of really starts to remove some overhead and kind of simplify kind of management and oversight in that way. So capacity management and planning. So ultimately, the function of capacity management is to achieve the highest performance at the lowest cost, right? We want to maximize performance. We want to do that at the lowest cost possible. But ultimately, that comes down to our specific application or application use cases. And I want to take a few minutes just to talk about kind of, in general, a couple of high-level type of use cases. So here, you can see we have modern applications, stateless batch, HPC, et cetera. And this application profile is going to be stateless, it's going to be fault-tolerant, highly flexible, cost-driven. And when we think about those characteristics, then the purchasing option or the purchasing strategy, compute acquisition strategy, is that we're going to want to leverage spot, right? Because that's going to allow us to maximize access to capacity by being flexible. Savings plans, which is going to allow us to maximize our discounting where appropriate, and kind of on demand. So this is one of those cases where there potentially is an excellent fit for all of these purchasing options, and you're able to deploy them based on your needs. The next one is where we're going to have a workload and it's going to have high compute demand. It's still spiky and kind of unpredictable, and it might run for a smaller period of time. Those are understandably a little tricky, where we're going to want to work to identify the right balance between capacity reservations, kind of for that steady state kind of baseline, and flexibility across locations and instances. Like I said, the key thing that I always want to talk about there, I always want to point out there, is again realizing and understanding that we have options, we have flexibility, and in a lot of these cases we can mix and match, based on whatever makes the most sense for our business or organization. And then ultimately, kind of this last use case, right? Databases, accelerated computing. These are highly performance sensitive. They're generally going to require specialized hardware, not really flexible, but you do have kind of predictable runtime patterns. And ultimately, that's where, in most cases, capacity reservations are going to be a great fit for us. And I'll talk about those here in a little bit. And I think that little bit is probably now. So sometimes we have situations that we need higher levels of availability for business and mission critical workloads, DR, maintenance, regulatory requirements, peak events, et cetera. We need to know that we will have the capacity that we need, when we need it, where we need it. And that is where on-demand capacity reservations come into play. So on-demand capacity reservations are great for a couple of reasons. One, they allow us to separate and manage our capacity independently of our discounting. They're also are no commitments required. You can create a capacity reservation on demand, you can cancel it on demand, so there are no long-term commitments to be able to do that, which I think is, from my perspective, really important. You're able to, of course, reserve that capacity by instance type, tenancy, AZ, and placement group. Now, one of the important things to understand about capacity reservations in terms of how do we effectively leverage them is to understand that capacity is held, and you will be charged whether or not you instances, right? So that is the trade-off that we're making to say that this capacity will be held for you, potentially indefinitely, and of course the trade-off there is that the instances will be charged whether or not they're running. This is why when we leverage capacity reservations, we really want to be strategic about it. Oftentimes we have high SLA workloads that are going to be running nearly 24/7, and that is kind of oftentimes the situation where capacity reservations are going to make the most sense and make the most kind of value for us. Of course, they're also flexible in that you can share reservations across accounts. And you're also able to create capacity reservations that are either open, which effectively says that any instance type that matches the conditions that you set for the capacity reservations will apply to that capacity reservations, which is great if you're looking for there's like a general purpose type of workload and every instance type of a particular spec that's running, you want it to be covered. However, if you're in a large organization where there's a potential that other parts of your organization could be running an instance that matches the profile of the capacity reservation that you've set, and you want to make sure that only the instance types that you're managing, that you're responsible for, are going to attach to that capacity reservation, then you're able to make it targeted so that you're able to have instances that specifically target that capacity reservation. And that way, you're able to control and keep account of the instance types that are running against your capacity reservation. The capacity management lifecycle. So ultimately, it comes down to having a strategy, a broad kind of plan in terms of the way that we think about a lot of the concepts that I've talked about kind of so far here today. And so when we think about that, we want to think about kind of PAMO, right? The acronym there, right? We want to plan, we want to acquire, we want to monitor, and then we want to optimize. So when we think about planning, right? I always say, measure twice, cut once. In the planning stages, this is where we're kind of gathering that information in terms of understanding the workload profile. What does our application or workload need? Kind of what are the unique characteristics that we might need to manage for? What kind of assurance do we need, right? We want to be answering and thinking about all of these questions to, kind of upfront to help us kind of inform our strategy moving forward. As we progress through the life cycle into the actually acquiring the capacity and launching and procuring those instances, then that's where we want to think about kind of how we want to do that. Do we want to leverage auto-scaling groups? Do we want to leverage fleet? Should we be using attribute-based instance selection, right? So this is one of those places where we're really going to want to think about what are the specific unique benefits of each of those approaches, and do they accurately align to what we're trying to accomplish? And then we want to kind of apply whatever makes the most sense based on our answers to those questions. Next, we want to monitor. So ultimately, this is about, are we achieving the objectives that we set out to achieve when we implemented the approach that we took initially? If we are, then of course, we want to double down, we want to do more of that. But if we're not achieving the objectives that we intended, if we're not getting the capacity in the way that we wanted, we don't have the level of availability that we were looking for, or the cost isn't where we wanted it to be, then of course this is our mechanism that we can use to go back, understand what's happening, and then adjust accordingly, right? So, and the things we talked about earlier give us the flexibility to be able to do that. And then finally, we want to optimize. So we want to continue to optimize for cost. So that is, of course, understanding if we're leveraging the right purchasing options in the right ways. Are we using the right combination of things? Availability and performance, right? So, we want to constantly be looking and taking the data that we've gotten from our monitoring activities to understand, are we hitting the mark on the objectives that we set out. And if we're not, then adjusting, and if we are, how can we improve, right? So it's like, from that perspective, the things that we're doing are working, but are there additional things that we could do to further improve on the results that we've already kind of achieved? So I know what you're thinking at this point. You're saying, hey, Zoe, that sounds great, but how do these concepts, these techniques, these approaches, how do they work in the real world? And I say that is a very, very valid question. And for that, I am so happy to have Eric from Salesforce with me to tell you just that. Eric?
Thank you. So, hi, everybody. My name is Eric. I'm a principal engineer at Salesforce, and I'm here today to talk to you about capacity planning at Salesforce UIP. So what is UIP? Essentially, it's a big data lake. The letter stands for Unified Intelligence Platform. As we transition from on-premise to AWS, we had a couple of objectives. The first one was trying to improve capacity as well as availability, and at the same time, reduce costs if possible. Now, that's exactly what we did, and that's the story I'm about to tell you. Now, Lorenzo was talking about balancing capacity, availability, and cost. So what were the different elements that we have in our case to do so and make this work? The first one was we had a fault-tolerant workload as we were using Spark as the main processing engine. And then we had SLA-sensitive as well as non-SLA-sensitive workload. We had ingestion in 5-minute windows, and this proved to be very important as we transitioned to using spot instances. What it means, essentially, is that every time there's a reclaim, it has a very minimal impact into the overall processing. And finally, we were willing to trade performance versus reduction in cost in some cases. In terms of provisioning, we tried many different scenarios over a couple of months, and what we found out worked the best is to use capacity reserve for anything that you really need. For example, our coordinator nodes had very specific technical requirements, and as such, if they were not present, they would simply fail our deployment, so capacity reserve for those. And then we will use saving plan versus on-demand, in a sense where we would be able to potentially use different alternatives. For example, we would look for an R524, but if it wasn't available, we will simply use 2 R512. And then we will use everything else as spot instances. And once again, we tried many different ratios here, and what we found out worked the best is 60% spot for SLA-sensitive job, and 90% for non-SLA sensitive. Now, in terms of region and availability zone, we are present in 2 regions as well as 3 availability zones. And that gives us 2 main benefits. The first one is capacity. As you leverage more location, you can actually have more capacity. The second one is the fact that it gives us flexibility to deploy our deployment, not deployment, but our cluster/fleet in a way where it could actually make sure that they wouldn't compete with each other. The second element in terms of flexibility is the fact that we could actually target the AZ where the spot pricing was the most interesting for each fleet. Now, as we started to build our fleet, we started with memory-based fleet with our instances. And then we went to what we call balanced fleet, called that because it was kind of an in-between. And that was based on M instances, and then compute fleet based on C instances, where each of them provide a different ratio of vCPU to memory. So memory fleet is 1 vCPU to 8 gigs of RAM. Balanced fleet is 1 to 4. and compute is 1 to 2. Now, this worked fairly well for a fairly long period of time until we hit some workload that actually needed more resources and more capacity. So this is where we said, hey, if it actually worked on 1 to 4, it can probably work on 1 to 8. So we started to do what we call mixed fleet, where we mix 2 instance family together, in this case, M and R instances, in order to increase capacity. But it also had a very big benefit that we were not really expecting, but came in, is the fact that it increased stability in our fleet significantly. So if there's one thing you need to remember from this talk, is the fact that the more instance types you use, the better capacity you will get, as well as stability in your fleet. Now, other things you should also consider as you build your fleet, local SSD versus EBS. Local SSD can give you a lot more performance, but if you consider the number of instance type you can use, sometimes it's actually beneficial to use both SSD and EBS simply to increase the number of instances you can use and overall the capacity. Network and EBS bandwidth. This one doesn't really concern when you use bigger instance type, but if you go to the smaller one, let's say you go to a 4 or a lower, this is where the bandwidth is usually lower and it could affect your performance. In our case, it did, so the lowest we would go would be 8XL. And then AMD versus Intel, and don't want to start a debate here, but overall, what is the best solution? Essentially is to use both, and that's what we do most of the time. We leverage AMD and Intel in the same fleet, and that gives us essentially more capacity. So as you build your fleet, you should consider that, there's, Lorenzo mentioned about 700 different instance types. You should try to leverage different instances. And as you go through that, you'll find maybe some Perl where, they might be too expensive on the on-demand side, but as spot instances, they might actually be very affordable. And the other element that I'd like to say about that is that you should try to iterate as much as you can. What you will do as you iterate is that you'll improve your fleet. In our case, it would take about 2-3 hours to make the configuration change, redeploy, and then see if it actually worked or not. Now, in terms of elasticity, in our case, what we did is that we deployed our cluster and fleet as auto-scaling. We defined the max scale of the cluster based on the SLA, and then we had another 5% on top of this. This 5% is essentially there for reclaim. If there are any reclaim, then they're covered by that 5%. If not, then the workload simply works a little bit faster than expected. We leverage compute saving plan on the follow the sun mode. And what I'm trying to say here is that when the workload increases in the US, it usually goes down in Asia and vice versa. So as we are present in multiple regions, it allows us to use our compute saving plan very efficiently. We use more spot instances when needed. So this one, what we do is that we always have a cluster that is in standby mode. And essentially, it's based on a fleet that's using spot instances. And when this burst in workload happens, we simply scale the cluster and use more spot instances in the process. Now, this worked for us because we're leveraging multiple instances, 60+ instance type over 2 generations of EC2s. A couple of things that I think Lorenzo mentioned already, Spot Advisor. In our case, we tried not to use anything that has a reclaim rate above 20% because it simply introduced too much instability in our fleet. He also mentioned spot placement score. What we do on our side, since our fleet are based on vCPU to memory ratio, that's the criteria we are using to enter in this tool. And then we had more instance to the request until we see different numbers in the score. At that point, we can see, okay, this is the right place to deploy our fleet. As you can see in this slide, it seems like AZ1 and 2 are a better place to deploy this fleet. Now, in terms of spot pricing, a couple of things you should know. The first one is that spot pricing will vary significantly between one AZ to another. As you can see here, B versus C, huge gap, but there's also significant difference between A, B, and C. So keep that in mind as you define your placement strategy. The other element that is important in this slide is the fact that the spot pricing will vary during the same day. So some people say, well, it doesn't, but it actually does. If you look into a week, you will usually see a spot pricing that is higher at the beginning of the week, and it will go down at the end of the week and the weekend. If you look at the longer period of time, this is where you'll see that there's huge fluctuation in terms of pricing, and that's kind of expected. So my recommendation to you is to make sure that you revise your fleet composition as well as your placement strategy on a monthly basis. Now, overall, we save about $1 million a month plus by using this strategy. We were able to increase capacity as well as availability. And overall, I think it was a main part of our success in our transition to AWS. Now, if you're interested to know more about what we did at Salesforce UIP, we work on a case study with AWS that goes in a lot more detail than what I've covered today. The link is at the bottom of this slide.
And before you go, I'd be remiss if I didn't talk about just one more thing. Amazon EC2 capacity blocks. Has anybody heard about this yet? Capacity blocks is a new EC2 purchasing option that enables customers to reserve capacity, GPU capacity, on a per-job basis for their ML training and experimentation workloads. Kind of some major points here is that capacity blocks will allow us to kind of better plan our ML projects around capacity availability because we will be ensured that the capacity is available and reserved for us at the time that we've scheduled. Again, pay only for the compute time that you need. So this is kind of really important when we're talking about GPUs and we're thinking about acquiring GPU capacity in particular. We want to be able to have flexibility around when we do that, right? So if we're not looking to make a longer term commitment, if we're trying to understand kind of the characteristics of a particular workload, the capacity blocks allows us the flexibility to be able to do that, be able to get large amounts of capacity, but with no kind of really long-term commitments. And then, of course, we're able to get low latency, high throughput network connectivity. The capacity blocks is built inside of an EC2 Ultra cluster to optimize for latency as well as network throughput. Another thing I really like about capacity blocks is kind of the ease of use. It's really as easy as booking a hotel reservation or a flight in terms of the way that you would do it. We see here kind of this example, customer on the 27th of October, they're thinking about reserving GPU capacity. They ultimately determined that they'll need about 16 of the P5 48 extra large GPU instances, starting on November the 2nd and going through November the 9th, so over a 7-day period. They're able to enter those requirements inside of capacity blocks and, in this case, get a return date that says, hey, yes, we have that capacity block available for you. It will only return one block. So that's, I think, a great point there, is that you're not going to be overwhelmed when you input your requirements for kind of GPU capacity here. You're not going to be overwhelmed with tons of options. It's going to only return one result if possible. It's only going to return one result that matches your criteria. And then, of course, if you're looking to do something different or that doesn't quite fit, then you want to go back and want to kind of change our criteria. But you're going to get this one kind of result. You're able to lock that in, and then you're able to confidently plan that you'll be able to run your training or your experimentation projects in the allotted time with absolute confidence that you will have the GPU capacity available at the time that you need it. Customer, in this case, you would run whatever workloads that you were looking to run during that period. And then on that last day, at approximately 10 minutes, you'd get a notice saying, hey, this capacity block is about to end, and that's our trigger to do any kind of checkpoints or wind downs that we're going to be looking to do there. So when we think about capacity blocks in relation to capacity reservations that we talked about a little bit earlier, the question a lot of times from customers comes is, when do I use which? And in this perspective, I think you really want to think about it in terms of capacity blocks being not a replacement for on-demand capacity reservations, but really an augment of them, right? So we're going to use capacity blocks for kind of those short duration things that kind of exceed our steady state needs, right? Where we're looking to train a new ML model, we're looking to do some experimentation, but we're really not ready to make a large commitment to that. Then capacity blocks is going to be what we're going to leverage there. But if this is one of the things that we're running at a larger scale, we have that kind of steady state usage, then that is where capacity reservations is going to be a better fit. And just kind of as best practice, understanding that capacity reservations from a pricing perspective, you'll be charged whether or not those instances are running or not. Best practice is to combine capacity reservations with savings plans, right? So we separate our capacity acquisition from our discounting. So when we think about kind of key use cases for capacity blocks, of course, train or fine-tune ML models per your schedule. I think that's a kind of a really important one in terms of thinking about planning, being able to plan into the future and know that you're going to have that GPU capacity available when you need it. When we're looking at building generative AI workloads in an efficient manner, right? So being able to secure that GPU capacity that we need, reserving the right amount of capacity for the time that we need it in the quantities that we need it for each phase of deployment. And finally, to conduct research experiments, right? So, we're always about continuous learning, and capacity blocks gives us the flexibility to do that in a really effective manner and be able to get kind of uninterrupted access to that capacity for experiments and prototyping. So finally, kind of our key takeaways. The key to finding the right balance between capacity, availability, and cost is flexibility, as we've discussed. And that is flexibility across instance types. It's across time. It's across location. It's understanding that we can mix and match purchasing options to maximize whatever we're looking to achieve with a particular workload or architecture. Kind of as that second bullet, right? When it comes to which purchasing option you use, do I use on demand? Do I use spot, savings plans, ODCRs? Ultimately, the answer is that it's all of them, right? It's an and. It's not an either or, it's an and. You have the control to mix and match them in whatever way you see fit, and I highly recommend that you do. We want to use the capacity management lifecycle, so PAMO, right? So plan, acquire, monitor, and optimize. So we want to think about that as a kind of broad framework for the way that we think about how do we take advantage and how do we maximize capacity, availability, and cost. And finally, if you need more agility and flexibility when it comes to GPU usage, don't forget to check out EC2 or Amazon EC2 capacity blocks. As always, we want you to continue your compute learning. Excuse me. We want to continue your compute learning. So I definitely want to make sure I mention the latest AWS Technology Compute Badge. allows you to expand your knowledge with AWS Skill Builder. You can use our AWS ramp-up guides to build your compute knowledge and dive deeper on some of the concepts and constructs that I've talked about here today. So highly recommend folks check that out. And lastly, thank you so much. Please fill out the session survey in the mobile app to help us continue to improve. I appreciate you all so much for joining us here this morning. Thank you so much. And if we have any questions, we'll be happy to answer them. Thank you.